So what's the best way to create a thread? There are two ways to create a thread. First, we extend the thread class. Second is we implement the runnable interface. We will see that by going to an IDE very soon. Why do we need a best way to create a thread? Why is this question coming? This question comes because there is some overhead which is associated when we extend the thread class, and we don't want it to extend the thread class every time. Ideally, the best way is the second one, to implement the runnable interface. Why is it so? Because when you try to extend this class, any class in Java, you cannot do multiple inheritance. Only one class you can extend. If you already extend thread class, it is defeating the purpose of inheritance. What we want in inheritance, there will be a child class which will inherit something from the base class. Now, if thread class only you are extending, you cannot, for your rest of the functionality, you cannot essentially inherit any parent class which will have some functionality which you want to have in your child class. That is the first point. Second is, when we create a thread class, as we will see in the code, every thread will create a different object. So that also is creating a different, like it's more overhead. You are doing new thread every time. Just because you've extended the class, you have to create an object of it. But what we will see is, when we are implementing the runnable interface, on the other hand, we are sharing the same object to multiple threads. Same object as in the object, the instance of the class. We use new operator to create an object of a class. So that new and the class name we are doing only once. And then that object only we are reusing to spawn or create multiple threads. So let's go to the IDE to see that. So here is a custom thread class that we have created. Now we are going to use this class to create our threads. One, using extending the thread class, and second by implementing the runnable interface. First, we will extend the thread class, which is part of the java.lang package. Next is we have to override the run method, which comes as part of this. So basically, if we take a look at the thread class, this is also implementing the runnable. And if we take a look at the runnable interface, there is an abstract method called run. We know that in case of an interface, if there is any abstract method, it provides like a contract. Like basically, interface will definitely have abstract methods, and we have to provide an implementation for that. So the same goes for here. So we will provide an implementation for this. What we'll do is we will override the run method, public void run, and we are just going to print us out that this is my custom thread that's run. Now going into the main class, what we have done is we have created an instance of this class already. And then we have used a start method. So start method is basically to spawn a new thread. Like it will create a new thread, in other words. But when you call the run method, when you are creating a new thread, it basically goes into a new state. Like it's like a child, it's newborn child kind of a thing. Then it has to run, right? So when it has to run, it goes into this run method. Whatever the implementation is there, it is going to be run. So the run method being called is nothing but your new state. From the new state of the thread, it goes into the runnable state. So now let's run this and see what happens. So this is how we are creating a new thread using extending the thread class. You see that we are creating an object of the class, and then we are calling the start method. If I have to create another thread, I again have to create another object of this, like T2, and then I have to create a new instance again, like new of my custom thread class. And then I can do T2.start. So we can clearly notice an overhead of, I have to do a new and then create an object of my class every time I want to create a new thread. But we will see that we don't have to do this in case of runnable, when we implement the runnable interface. So let's try to implement the runnable interface over here. The same code, it is going to be the same thing, but if you come to the main, now you'll see there is an error. Why this error is happening? Because in runnable interface, we saw there is only run method which has to be overridden. Start method was not there. What we have to do instead is, I'll just comment this out. Firstly, we have to create an object of the class that we want. Then we will use the thread class, and then we are going to do something like thread T1 equal to new thread. We are calling the constructor new thread. Within this constructor, we are going to pass in our T1, and then within this new constructor, we are going to pass in our object, that is my custom thread, and then T1.start. First, we are creating an object that remains the same. Second is we are invoking the constructor of the thread class by passing in the object of our class. If you see into this, it is taking a runnable as one of the parameters. There are many different overloaded versions of the constructor, but we are using this one where we can pass an instance. Why we are passing an instance? Because we are implementing the runnable in the my custom thread. Now, when we implement this, my custom thread becomes the concrete implementation of the runnable interface. So we are passing an instance of that into the constructor, and then we are calling T1.start. Ideally, it should give us the same result. Yeah. So now what is the difference? So here what we were doing is we are creating an object that remains the same, and then we were doing t1.start. The main difference is I only have to create this object once. Suppose I want to create another thread. I'll just do thread t2, and then I'll again call the constructor, passing in my same object. The object of the class remains the same. I just have to call this. I just have to call the constructor of the thread class by passing in my existing object only. And in this way, I can create n number of threads. So if I go into my class again, just to differentiate which thread is running, there is a method, there's a static method called thread.current thread.get name. This will automatically give like thread and then the numeric value to it. So this will tell us which thread is running. So let's try to run this. Now in this case, because we have T1 and T2, both the threads are going to run concurrently. So we can see first thread 0 and then thread 1 is running, T1 and T2. Okay, so this is how we are creating thread using the two approaches, and we have seen that why implementing the runnable interface is a more recommended way of creating a thread.